Hello everybody, today we are going to be talking about naming and writing of chemical formulas for ionic compounds. Ionic compounds are those that are made of metals and non-metals. So we are talking about anything from the left side of the periodic table. So if we're talking about our periodic table, we're talking about this is the metals and the non-metals are generally over here, non-metals. And so let's take a look at some of these rules. We're going to start with writing formulas for ionic compounds. So in order to write the formula for an ionic compound, we first write their symbols. We assume that the metal ion is always going to be positive or a cation and will be written first. The non-metal ion must be written last. We find the ionic charges for each of the two ions and then we need to find a way to make the total charge 0. Once the charges are balanced, we can use the subscripts to write the formula out. So let's write out calcium fluoride. So we find the symbols for calcium and for fluorine or fluoride are calcium and fluorine. Then we write their ionic charges. Calcium is a 2 plus because it is in the second row of the periodic table, second column. Fluorine is in the second last column, so that makes it a -1. Now, to balance them, we must multiply these by a certain number of repeating units to find the formula. So one way to organize your thoughts here is to uh, think about this as sort of 3 rows and say right now we have 2 times 1, which gives us plus 2 on the bottom, and that has to be equal to the charge of the fluorine. So that means that for the fluorine, I have something minus a -1 times some sort of charge, and that's going to be our final value. So let's think about it like this. We have a -1 fluorine. What do we have to multiply it by to get to an equal but opposite charge to the calcium? Calcium's plus 2. I'm going to need 2 here to get a total of -2 charge. And that 2 is going to be placed right here in the subscript. So I'm going to write it as calcium F2. Another good representation that I like a lot is to use sort of these building blocks. So I like to think about it as calcium is 2 plus. So I put 2 pluses like this. And I need to make it equal to the fluorines, but each fluorine only brings a -1. So you can see that there's a gap there where there's no equal. So I need to make 2 of these, copy and paste them here to get the equal charges. So now that the charges are equal, that means that I have 1 calcium and 2 fluorines. And to represent 2 fluorines, we know that we write the number beside the symbol and to the bottom, or subscripted. Let's check out magnesium chloride. Magnesium chloride is also in the second column with calcium. So magnesium will be Mg2 plus, and chlorine is in the same group as fluorine, so it will also be Cl minus. So how many chlorines do I need to balance the magnesium charge? Well, by the same logic we used before, we have a plus 2, so we have a total of plus 2 under the magnesium. Right now we have only a -1 on the chlorine, so we're going to need to multiply that by 2 to make it balanced. That means we're going to need 2 under the chlorine. So our total is going to be MgCl2. Essentially an identical formula as our calcium fluoride. Just going to get rid of that. So there's our final answer. Let's look up barium nitride. This one's going to be a little tricky. So barium is in the same group as magnesium, so it is 2 plus. A nitride means nitrogen. And if you want, we can provide you with an ion table, and you'll find that nitrogen, as the ion nitride, has a 3 minus charge, or -3 charge. So how do we balance these two? A little bit trickier to do. we have currently barium, there's only one of them, so we have a +2 charge, and the nitrogen has a -3 charge. So we need to multiply these by two different numbers so that when we add them together, they equal 0. So what could we multiply the barium by so that it adds up to 0? Well, let's say we multiplied it by, we can do the work here. We could try pretending that we multiply by 2. That gives us +4. Well, that's more than -3. So let's multiply the nitrogen by 2 as well. Okay, we're now at -6. Still not equal. What if we increase the barium by another count? So we have 3 bariums now. 3 bariums times 2 is +6. 2 nitrogens times 3 is -6. That would be balanced. So that means that we would be talking about barium 3, nitrogen 2. Like that, Ba3N2. I'm going to show you how that works with the other method, with the sort of schematic that I drew earlier. So let's try that one as well. So here we have a barium, which has 2 positive charges, and we have a nitrogen, which has 3 negative charges. Now we're going to do a little bit of work. We see that the barium is short a little bit, so we duplicate it. Now we cannot cheat. We cannot add any more or less. We see now we are short on nitrogen, so we duplicate the nitrogen. Okay, nitrogen's almost, now there's way too many nitrogens, so we duplicate the barium again, and there we go. So that's balanced as well. So we can see the other way of balancing there. We can't cheat. We can't use half a charge. You cannot have a barium that only has a +1. That's not allowed. These must be following the rules that we've established. All right, the last one here is sodium sulfide. Sodium is Na, which is in the first column, so that's +1. And sulfide is in the second column is in the same column as oxygen, so is 2-. So what is the balance going to be? Well, we have more charge in the sulfur, so we want to multiply the lower charge. So multiply the sodium. What if we multiplied by 2? We multiply by 2, we would have 2 sodiums and 1 sulfur, and that would be balanced. So as a tip, let's put a little tip here. Focus on the one you have the least amount of charge. So focus on adding ions of the charge you have the least of. So you can see in the previous example, I had the least amount of positive charge with the sodium and the sulfide. So I focused on that one, and I purposely focused on the positive charge and made sure that that was solved first before I moved on to the negative charge. And in that case, I didn't have to move any farther. Now there is a method called the crisscross method. Some students really like this one. Here you take the 2 charges. So let's write aluminum. Oops. I'm in the wrong mode here. So aluminum sulfide, we write our charge for aluminum 3+, and our charge for sulfur 2-. And then we perform what is known as a crisscross. We take the 2 and move it down, and we take the 3 and move it over. And so the result is Al2S3. And if you want to check that work, it is balanced. This also works for barium oxide, but if the 2 numbers end up being the same, we should ignore the crisscross. So barium has 2+ and oxygen has 2-. The first thing we should check is that the numbers are not equal and opposite. So if the 2 numbers are equal and opposite, I might get some students who do this, and they're going to write Ba2O2, and this is unfortunately incorrect. Because the numbers are identical, we should have gotten rid of them and just write BaO. So maybe we should need to write a little rule in here. So before crisscrossing, crisscross, check if numbers are equal and opposite. If so, no balance needed. Okay, so just watch out for that. There's a couple of other examples too where you might end up with a multiple, and that way you can also simplify. So let's write out the chemical formula for copper fluoride now. So copper fluoride, this has a 2 here. That means that the copper is considered 2+. So that's what this 2, it's a Roman 2. So that's a 2+, and the fluorine is minus. So we're going to do the same crisscross. We're going to take the 1 and move it down. We'll take the 2 and move it over. So copper F2. Copper has a 1 beside it, and the fluorine has a 2. Iron 3 chloride, Fe3 plus chloride minus crisscross. The 3 goes over to the chlorine, the 1 goes over to the iron. So it's iron Cl3. And aluminum sulfide, Al3 plus and S2 minus. We already just did this one. We just did Al2S3. And finally, lithium oxide. Lithium is +1. Oxygen is 2 minus. So we do the crisscross. The 2 comes down, the 1 goes over, and that results in lithium 2O. So notice this method does not work all the time. However, here are 2 examples where most of the time where it doesn't work. And when crisscrossing, you will sometimes find it necessary to reduce the subscripts to the simplest ratio. And so a example here is aluminum nitride. I don't know what this is talking about. It does not give you an example. So there are a couple of examples where it doesn't. This is talking about this one here, that barium oxide, where we should not use, we have to reduce the ratio to the simplest ratio. Aluminum nitride, did we do this one already? I don't think so, but let's just do this one. 3 plus N 2 minus. Do the crisscross, that one works out all fine. Al2 Al2N3. Okay, write the formula for the ionic compounds formed from each ion pair. Hopefully you can work your way through these, but if you want to pause the video, then come back in 1 second and I will have the answers for you. So please try to do these 3 examples right now, and I'm going to stop for 1 second, count to 10. Okay, hopefully you've had a chance to pause the video and then come back. Here we have the equal and opposite charges, so this would be magnesium oxide. Notice we do not need to do any crisscross here because the charges are equal and opposite. Gallium arsenide, again, equal and opposite. We do not need any charges. We do not need any subscripts. And barium and sulfide also don't need it. So that's kind of a trick set of questions there. All right, I think we will pause there. We'll do a little bit of chemical formula writing, and we will come back in our next video to do some naming. Good luck out there, and we will talk to you soon.